Hello everyone. Today I am starting new topic. This is your linked list. From here, this is your linked list. So wait for some time. So what is the linked list? Linked list means this is your another type of data structure where we have to put our data in sequential way. Okay, so it's also taking the data and a pointer. Pointer means generally taking the address of that data. Okay, so linked list is a linear data structure in which the elements are not stored at contiguous memory location. Means a linked list is a dynamic data structure. What is the meaning about the dynamic data structure? It's like wait. Dynamic data structure means generally firstly your static data structure that we are declaring during the compile time, and dynamic data structure like when we run that program, and after the running state it will take the memory according that, and we don't have to write that like firstly we have to initialize the point of memory, how much memory we are taking according the array, because array we have to declare the size of a particular array, like how much data I really want to insert in that site list. So in dynamic type, during the execution and during the running time, we can shrink and we can compress the data and size of the linked list according your need. So the number of nodes in a list is not fixed and can grow and shrink on the demand. So it's really sufficient and really efficient to store the data, because according that running time we can shrink and we can grow the memory according your requirement. Okay, so each element is called a node which has 2 part. First is your information which are collecting to it information, that is your first information. Second is your pointer. Pointer means address of that variable, like if this is the information and it's taking the data, which data I'm inserting inside the linked list. Point means is pointing and it's like taking the address of this next node which is present here. Okay, so this is the starting point. We generally some like something about it is starting point, we generally call it head node, and sometimes we generally call it starting node. And at the last node it always show the null pointer, because it so it doesn't have any further node, it doesn't further node, so it can't collect any information to further node, so that's why it has null information. Okay, so this is the data pointer. Now I am moving next. Advantages of linked list. Linked list are dynamic data structure, like that is they can grow and shrink during the execution of the program. Okay, efficient memory utilization means here memory is the free allocated memory is allocated whenever it's required, and it's deallocated when it's no longer needed. Like I don't have further data, and that's in that case I can easily to shrink that linked list during the running time. If I have a lot of data again and again. I'm just inserting inside the linked list that I can easily grow that linked list again and again, again and again. So this will be sufficient for utilizing and for inserting the data inside the linked list. Insertion and deletion are easier and efficient. It's provide flexibility in inserting a data item at the specified position and deletion of a data item from the given position. Like we can delete the node from any point, like at the starting, at the end, otherwise in a middle point. So it's different techniques to deletion about any related any nodes. So many complex application can be easily carried out with linked list. Okay, so operations of the linked list, basic operations to be performed on the linked list. Some first is your creation, second is your insertion, then your deletion. Creation means this operation are used to create a linked list. So in this node it is created and linked to the another node. Insertion means this operation is used to insert a new node in the linked list. A new node may be inserted. Okay, so at the beginning of the linked list, at the end of the linked list, and at the specific position in the linked list. Okay, deletion means this operation is used to delete an item from the linked list. A node may be deleted from. Okay, so beginning of the linked list we can delete the element, and element delete the from the endpoint and specified position in the linked list. Okay, and traveling means it is the process of going through all the node of a linked list from one end to another end. Okay, concatenation means it's the position of the joining the second list to the end of the first list. Okay, display means this operation is used to print each and every node information. So type of linked list, we have a single linked list, doubly linked list, and circular linked list. Basically, four type doubly circular linked list and circular doubly linked list. Okay, this is. So now firstly single linked list. Single linked list we have only starting node and it's taking the address of these this information of 10. Okay, and it has only two parts, first taking the data and second taking your pointer node that is taking the address of the second node. Okay, wait, a second node है ना, then it's going to next 20 is taking the further node, and last one is your null pointer. Okay, doubly linked list means it has three pointer, it has two pointer and one data information. Starting node is generally calculating, that is your starting node, that is your head, and it's containing the address part of the next information, that is your 10. So 10 is a data part, first is your previous pointer that is taking the address of the first node, and the second next pointer we can say here is your next pointer that is containing the address of the next node present here. So now previous node here is taking the null because it before this node no other node present here, so that's why it's taking the null pointer and null address. Okay, and same as last node also contain the null because further nodes present not here, so in that case it's containing the null pointer here. So last pointer is, this is your last where it doesn't have any information and any pointer here. So this is the doubly linked list. Same thing is your successor and predecessor node. So successor means generally this is your successor, and previous node that is your predecessor node where we initialize previous and next node. Okay, circular linked list. Circular linked list means last node address is taking the first node address. Okay, like it's the circular type, it's starting from here and taking the address of the first node. Same when we generally present on the last node pointer will contain the address of the first node. Okay, so this is the circular linked list. Circular doubly linked list means it's one which both the successor pointer and predecessor pointer in a circular manner. Okay, the area where starting node is this is taking the address of this node, and last pin pointer will give the address of the first node, and same is this last node is give the address of the first node, and last node also give the address of the first node. Okay, so this is the efficient way to utilizing the data when we are present in any node. Like in singly linked list, we do not have any requirement like if I are present on the further node and in intermediate and in the last node. So in that case, we can't go directly on the first node. We have to again cover the same node again and again, and then that is the worst and very worst condition. In circular, it's efficient way to utilize that, like we can easily to round that, and it can easily, if we are present on the end of node, we can easily to circulate other data accordingly. So insertion of node in linked list, inserting of the beginning of the linked list, inserting at the end of the linked list, otherwise at the specific position within the list. So that I am inserting 40, so I am starting here, I am really remove the connection between start and between this. Okay, so what I will do firstly, I will put the address of the starting node in this 40, and then I will connect to it. Then I will take the previous and address part of this node from here, and I will give the same position to this 40, and then will remove exactly point about the starting between and node present here. In second position, that is the efficient way to utilizing that information and address is present. If I'm just starting and I'm just inserting the node at the end, so where firstly I have to remove this, so I have to remove this. So firstly I will take another node where I can easily remove the connection in between that. So I will take the address of this node inside that. After that I will do the address of that node inside the 40, and then I will collect it, that is your null pointer, and that is connectivity in between is this. Okay, so sorry, yeah, so starting node is this, so I inserted accordingly, and this is the intermediate position where can a specific position within the list I am adding it. So firstly I will remove the connection between 10 and 20, then I will insert the address part of this 10 to inside the 40, and then I will make the connection between 20 and 40, and then will connected by this. Okay, so with the help of a another node, like we generally taking any temp variable, and inside that I'm inserting the previous node address, and then I'm again removing the connection between 10 and 20, and then I will give the address and pointer part to the 40, then I will making the connection in between that. Here is a simple way, just I'm explaining in front of you that how many ways present in linked list, so that I can easily remove and delete from a specific position. So linked list, inserting a node at the beginning in linked list, so that is algorithm. So insert first, that is start an item. Start, this is a start an item. So check for overflow. If your linked list already full, so what in that condition what will you do? So firstly we have to check the like this is the overflow condition or not. Then if pointer is equal to null, then print overflow exist. Okay, exit. Else ptr equal to node malloc is size of making any, if I am making any node, initializing any node, that time we are doing the malloc. This is the function where we generally making the new node with the help of malloc function. It's taking the size and particular item where we are inserting and we are making for that. So create new node from memory and assign the address to the PTR. Step 2 is saying PTR information, like PTR is a node, it's another node. It's taking the item, we are inserting the item inside the PTR information, and then starting next, what is the next of that PTR. Then I will inserting the starting address, and then if PTR has a starting address, then I am putting the starting position. so that time it will connect to the first position. Like I'm saying that easily, 40 is another point. So 40 means next of the 40 is next, like we are just call it the next, and 40 is the information. We are saying that information, so it's taking the item, which item I am just inserting, and it's taking the start address. Why we are generally start address? Because it's taking the address part of the 10. So address part of the 10 I am giving to the 40. Okay, so 40 taking the address part of the 10 again. Okay, so now ptr address, like ptr, what is the, this is the new, so this address is giving to the start. So from right now it's connecting to the 40 address, and 40 pointer it's connecting to the 10 address. Okay, so this is your inserting or at beginning. Inserting at end. Inserting at means same thing, start an item, so check an overflow condition. If ptr is a null, then overflow condition. So I am just making the any another node, that is your ptr again. So ptr information is taking the item, okay, and ptr next is taking the null. So starting position and then null, and then same ptr is connecting to the starting position, and else, that is the starting position of that ptr. Okay, same as this. So now 6 point is saying, like I'm just a specific condition to relate it. If you can see in example, it's a lock is another type of variable where we initializing 30 information, and then I'm just giving the address of the 30 to the 40. So firstly I'm putting the address to the ptr, then I'm making the connection in between that. Okay, same is lock next will connect to the lock, and then ptr address. What is the ptr address? This is the ptr address to connect it to the lock next. Lock next means 30 lock, and 30 lock giving the address of 40, 40 connecting to the 30. Okay, so it's making that. So insert a node at the specific position in the singly linked list. Means in algorithm is start item and lock. Check for overflow condition. If ptr is equal to null, then same overflow condition and exit that loop, and else ptr we are generally initializing a new node. That if ptr information is item, I'm putting any item inside that, and then if start is taking the null, so ptr giving to the address of to the start, and ptr next will null, because it has only one pointer inside that. Because start position taking the null means it doesn't have any further node present there. So in that case only one node we are inserting in that side. In that condition, start will take the address of that 40. Okay, initialize the current one and pointer, so set I equal to 0, and temp taking the address part of the start. Okay, same is this, repeat the step 6 to 7 until I less than lock. So set temp equal to temp next. Temp next address will contain the temp, and I plus h means giving the I, and ptr next will contain the address of the temp next. Which temp next? Well, 20 address of the 20 present in temp, so temp will give the address to the ptr, and same address of the ptr is giving to the 40, and then we can easily specify the specific position of the 40. Okay, and last one is that temp next is connecting to the ptr address. Deleting node in linked list. Deleting node in linked list is specific position, like deleting the first node of the linked list, deleting the last node of the linked list, and deleting the node from the specific position of the linked list. That first node is deleting. So deleting the first node in singly linked list, like delete the first start position to check the underflow condition, like if it has node and present any node and node, so in that case we have to search this. Print linked list is empty and exit. If it has some node inside that, like its start position is giving to the ptr, and then start next is saying like this is the containing address of any node, and we put the start and then delete that element, and that is the free condition. Okay, so this is the chance of it. Now printing the PTR information, and that is a free is a function where we generally initializing any real-log and malloc function inside a link, right? That time we generally call the free function. Free that particular node. Okay. Deleting the last node in singly linked list, same underflow condition. We have checked this condition firstly, underflow condition, and then we generally starting from null pointer of that start because it's containing the address of the next node, and then start position giving the address of the PTR, and then null position is starting and print PTR and indef. Third position is saying if 1 to 3 like start position is containing the address of the PTR, then repeat 5 to 6 until PTR is not equal to null. Okay, so it's like not equal to null by saying, because last node we are deleting right now, so last node always taking the pointer is null, so that time we are using this condition. Okay, so this is the pointing. Linked list deleting node, these the same thing. Here algorithm you can see here deleting the location of start and null, so check for underflow condition, so PTR equal to null, so print underflow condition. So initialize the counter 1 and pointer set equal to I equal to 1, set PTR equal to start, so repeat 4 to 6 until, so this is the same condition for previous. So in this example you can see here, so print element and delete print, and that it's containing the specific position, and we are generally just shuffling it, like we are generally disconnecting to these, and we are generally taking any temp variable, and that inside the temp variable we are disconnecting 30 to 40, and then we are initializing the variable and address part of the 40 to the 20 directly, and with the help of the temp we are inserting the address variable to the 40, and then making the connection. Second data structure, that is your tree. Tree is a non-linear data structure in which items are arranged in a sorted sequence. This is non-linear, means it is not sequence. This is the hierarchical data structure, like tree like. So it is used to represent hierarchical relationship existing amongst several data items, like level 1 is starting from level 0 to level 30, sorry level 3. So this is the first node always saying trees, that is your root node, that is your left child, that is your right child, this is your left child, this is your right child. This is the hierarchy of the data structure. Tree terminology, tree are different terminology. Root is a specially designed data item in a tree, so it is the first in the hierarchical arrangement of the data item. Second, node, each data item is a tree is called the node, like these are the nodes, these are the nodes, these are the nodes. Okay, so this is the nodes present here. Now degree means starting from where and ending from where, so it is the number of subtree of the node in a given tree. Okay, degree of a tree, it is the maximum degree of node in a given tree. In the given tree, the node A and node I has maximum degree 3, so the degree of tree is 3. Okay, because it's going to up to 3 up till starting from 0 to 3, so this is your degree. Okay, now terminal node is a degree 0, it's called terminal node. The given tree, terminal node means inside the internal part of the node. Terminal node, E, J, G, L, these E, G, H means it doesn't have further node, that is your terminal node. Non-terminal, any node whose degree is not 0 is called the non-terminal node. Okay, siblings, the child node of a given parent node are called siblings. They are also called the brothers in the given table. Okay, level, the entire tree substructure is labeled in such a way that the root node is always at level 0. Age, it is the connecting line of two nodes, that is the line drawn from one node to the another node is called the age. Path, it is the sequence of consecutive age from the source node to the destination node in the given tree. The path between A and G is as. Okay, depth, it is the maximum level of the any node in a given tree. In the given tree, the root node A has the maximum level. Forest means it is the set of disjoint tree in a given tree. If you remove its node, then 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 it's become a forest. So in the given tree there is a forest within tree, so we can after arrangement about it. So this is the binary tree. Binary tree is a finite set of data item which is either empty or consisting of the single item called root and two disjoint binary tree called the left subtree and right subtree. So binary tree and tree, so every node can have maximum two children which are known as the left child and right child. Okay, these are the left and these are the right. Okay. Type of binary. Full binary tree means a binary tree is a full binary tree. Every node has 0 and 2 child. Complete binary tree. A binary tree is a complete binary tree if all levels are completely, okay, completely filled except possibly the last level, and the last level has all key as the left as possible. Okay. Perfect binary tree means a tree in which all internal nodes has two children and all leaves are at the same level. Okay. So now travels of binary tree, it is the way in which each node in the tree is visited exactly once in a systematic manner. There is three ways which used to transverse of that, like the pre-order, in-order and post-order. Pre-order means starting from the root node and then giving to the next to next. In order means I'm giving to the priority to root at the middle part. Okay. Post order means after, like at the end point I will give into priority to the root node. Okay, so this is the condition about it. So this is the pre-order traversal. Pre-order traversal means A starting from A and then it's going to the A to B. Pre-order means first node. At first which node is coming, then I will put the pre-order condition. A is coming at the first, then I will put A, then B, then D. Again I am going to D. At next time not I put here. Then next time D. Then first time E, then E. Then next time first time C, then C, then first time F. So pre-order means first time which node is coming, then I am mentioning. In order means second time which node coming, then I am mentioning. Post order means third time after traversing, during the traversal time coming, that's I'm putting the sequential thing here. So this is the in order, pre-order and post order conditioning. This is the in order in which the traversal method, the left subtree is visited first, then the root, and later than the right subtree. So until the node are traversal, so right equal left subtree and visited node and traversal. Binary subtree. So binary search tree means this binary search tree is a node based binary tree data structure which are following rules. The value of the key in the left child or a left subtree is less than the value of root. Okay. The value of right subtree always greater than to the root. Okay. And right and left subtree must also be binary subtree. So this is the condition. So post order traversal means after the traversal I am just giving the third part of this. Okay. So this is the stack and queue relationship, like it represents the collection of element in last in first out. It's using the FIFO condition. And second position, its object are inserted and removed at the same end top of the it's inserted and removed from the different end, that is your front and rear. And insertion operation is called the push. Okay, insertion operation called in queue, inside the in queue operation. And it's deleting position from the pop, it's deleting from the DQ operation. And its take is no wastage of the memory. Q, there is a wastage of the memory space. And plate convert a marriage reception is an example of the stack. The student standing in a line at fee counter is an example of Q. So this is the some type of data structure I presented in front of you. I hope you will like it. This is the basic part and starting from programming skill and improving your skill in direction of the programming and just doing and finding the complexity and searching the execution time. So this is the good approach to handle it. Like we talked about, the linked list is a really efficient way to we are using arrays, so that is your predefined size of the array, but in linked list we can go and shrink during the execution time. So this is the also sufficient manner to utilize it. So Thank you for this. I hope you will like it. Thank you.